7.2 here, making confidence intervals for population proportions. 7.21, we have a poll of 1,000 people, and this number here are in favor. So first, I want to, let me zoom in here a little to make my numbers bigger. So we had 480 out of the 1,000 in favor of the fire department bond measures for this problem. So the sample proportion is 0.48, 480 out of 1,000. So that's what I would want to type in here, and just confirming that down here. Now the margin of error for 90% confidence level, first you're going to come up and look at the critical value you need, which is 1.645. And we're going to use this formula here, whatever that critical value is. And for 90%, it's 1.645. We need to look at that sample proportion we just calculated. We're going to take it and multiply it by 1 minus that. So let me come over here and do that. This is P, and I'm going to do 1 minus P. All right, so I got 480 out of 1,000 is P. So then 1 minus that result, 1 minus that is 0.52. These two things should always add up to 1. They accounts for 100%. So those two things add up to 1. That goes on top of the formula, and on bottom we divide by how many there are. In this case, there was 1,000. So let me go ahead and work that formula out. I'm taking on top this value multiplied by 1 minus P, so that those two things multiplied, and divide by the sample size, which in this case is 1,000. We want the square root of that. All right. So I like to break it up into steps rather than try to type it all in at once. The square root of that, once I've done and captured that square root, I multiply it by the correct critical value based on the level of confidence. In this case, it's 90%, so multiply by 1.645. So this is going to be my final answer here, 1.645 multiplied by that square root I calculated. And that gives me the margin of error, which rounds to 0.026. For 7.2.2, now we have a two-tailed here. What proportion of students identify as Hispanic or Latino? That's the context here. Our sample size, 400 people we polled, 68 said Hispanic or Latino. So coming over here, let's kind of delete this work. But look at, again, just calculating that sample proportion. So 68 out of 400. 0.17, that is our population point estimate for the population proportion, what we just calculated. No, I can't click on the drop down anymore, but the parameter we're trying to estimate here is the total proportion of students that identify as Hispanic or Latino. And we're using our sample to do that. So our sample says about 17% of the sample do, so that's our estimate for the percentage of the population that identify as Hispanic or Latino. All right, the data suggests I want to be able to click on these. There we go. The data suggests, we're going to use this confidence level of 95%. So the data suggests that a 95% confidence exists, so just match it up to what the value you see there, that the actual proportion for the entire population who identify is somewhere in between, and we're going to find the upper and lower limit. And now, like with all confidence intervals, it's going to be centered around our sample proportion. So we need to find the margin of error and add it and subtract it to the sample proportion in order to get the upper and lower limit. Well, they already told us the margin of error in this problem. So I just need to take this value and subtract that margin of error. That's the lower limit. And then take that margin of error, take that sample mean and add sample proportion, and add the margin of error to get the upper limit. So sample proportion right in the middle, add and subtract the margin of error, and you have the limits of your confidence interval. And we're 95% that the actual population proportion of people who identify as Hispanic and Latino lies somewhere within between those limits. For 723, there's a spreadsheet to download here. It's telling me to use sheet 2. Excuse me, 75 customers. That's who we're polling, and we want to know if they came to the bookstore because of the coffee shop. So first, let's. I'm on sheet 2. Make sure you're on the right sheet. You want to use a formula in Excel that will quickly count the number of no's and yeses for you. So if, and then type in where the data starts. So if A2 equals yes, I'm going to hit comma 1. So if it's yes, it'll put a 1 there for me. And if it's a no, it'll put a 0. So as you can see, as I drag that formula down, next to every yes, you should see a 1. Next to every no, you should see a 0. And then at the bottom, you can just hit equal the sum, and it'll count up how many 1s you have. And that's the number of yeses you have. So the sample proportion in this example is 61 out of 75. That's the sample that said yes, they came to the bookstore. That proportion said yes, they came to the bookstore because of the coffee shop. Now we want to find the upper and the lower limits of a confidence interval. It's going to be centered around our sample proportion. Got to find the margin of error. So again, that formula we saw earlier in the video, we need to take that sample proportion, and again, I'm going to break it up here. What was it? 61 out of 75. So our sample proportion is 61 out of 75, and I want 1 minus that for 1 minus p. Those two things add up to 100%. So now working the calculation on top, I do those two values multiplied by each other, and I divide by then the sample size. Oops, close the parentheses. 75 here is the sample size. The problem states that, and you can see that in Excel as well. So divide by the sample size. Just following that formula, take the square root of it now. The square root of that result. So that's the number I need to multiply by the critical value. Pay close attention to the problem. It says 95% is our critical value. I need 1.96. Multiply that by what we just calculated. So that is our margin of error. So to find the upper and lower bounds, it's always centered around the middle. The middle is always the sample proportion. So I'm going to take that and I'm going to subtract the margin of error to get the lower bound. So lower. And then for upper, I'm going to again take the sample proportion and add that margin of error to get the upper bound. And those are the values that we're looking for here. And so, I mean, how you summarize that then, the summary statement is the manager has 95% confidence, that the true population proportion of customers coming to the store because of the coffee shop is in the interval, and it's going to be those same values again, the lower limit and the upper limit. So kind of the same answers you listed there. So that's where we can be confident the actual population proportion lies in between those values.